Slide 15. So we know that Earth's climate has gone through many changes over geologic time. And we know that climate, the locations of climate zones, the locations of biomes, where species are found, must also change in response to those climatic changes. What is different about the climatic changes that are occurring today and how particularly species will adapt or not to those changes is important to note, because unlike all previous changes in climate over Earth's history, today we have approaching 7 billion people on the planet. The environment has been severely altered or degraded so that it may make it more difficult for species to migrate into areas that have a climate that's more hospitable to them. For example, if there's a species that needs to migrate north, but there's a huge urban sprawl in between where that species lives and where it wants to get to, will the species be able to actually migrate through that urban environment? There's been a lot of environmental degradation. There's been compromises to both air and water quality. And unlike previous climate changes in Earth's history, this one is going to present some unique challenges to species. And let's not forget that we humans are one of those species. There are now political boundaries. People can't migrate across borders, political borders. And I like to bring up the case of Bangladesh, because Bangladesh is an extremely low-lying coastal plain, and it experiences monsoons and typhoons, cyclones in the Indian Ocean, with storm surge occurring regularly there. So this is an area of the world that sea level rise is going to severely impact. And as the people need to migrate to other areas that are higher elevation, will they be allowed to cross those political borders and boundaries into, say, India, for example? Slide 16. So let's focus on, for a moment, the highland climates and how might climate change or climate warming impact species in a highland climate. So first of all, highland climates, the map from your textbook with the gray-toned letter H, these are found all over the world. They're not limited by latitude, for example. They are areas where you have major mountain ranges, mountain belts. So we see along the west coast of South America, the Andes Mountains presents a highland climate zone. In Central America, we have highland climate zones. In North America, again, it's all kind of geared towards the west coast, and that has to do with plate tectonics, which we'll talk about in some future lectures. Of course, the Himalayas is a huge region of highland climate. And then also in Eastern Africa, the Eastern African Rift Valley, where there's a lot of volcanoes, there are many highland climate zones there as well. So just a word about highland climates. A highland climate, think of it as having vertical zonations in both temperature and vegetation, and then the other kinds of species that are living in that ecosystem. So as we increase our elevation up a mountain slope, for every 1,000 feet that you climb, it's the environmental temperature gradient, or the vertical temperature gradient, drops by 3.6 degrees Fahrenheit for every 1,000 feet that you climb. In addition, atmospheric pressure will decrease with increasing elevation. So these two factors of decreasing temperature and decreasing atmospheric pressure present to us zones of land. And in the figure here on slide 16, we can see a cross-section of a mountain slope. And let's say that this is in Central America, because in Central America, that very narrow isthmus of land has the Pacific Ocean side, and it has the Caribbean slope. So on the left in this figure is the Pacific, on the right is the Caribbean. And as you climb any of those mountains, and most of them are volcanic in origin in Central America, you're going to pass through these zones and notice that these are Spanish language terms. So the lowest zone, close to sea level, going up to maybe, say, 2,000 feet, is Tierra Caliente, hot, right? And then we get into the Templada. And then as we increase in elevation from, say, 5 to 9,000 feet or 10,000 feet, we're in the Tierra Fría. And then ultimately the highest portion is the Tierra Helada. So I actually had the pleasure of hiking to the top of the highest mountain in Costa Rica called Cerro Quiripo, which has an elevation of over 3,800 meters, so like over 12,000 feet. And from the top, it is said that you can see both the Pacific and the Caribbean, or, Atlantic, if you will, oceans. Now, when I was there were clouds, so I couldn't. But you basically climb from this very hot environment up to this icy, cold environment. And I, to this day, have not experienced a colder night than I did when I camped at the top of Quiripo. So, okay, climate is changing, climate is warming. So as the climate warms, each of these vertical zones is going to migrate north. In other words, the Tierra Caliente is going to extend to a higher elevation. The Tierra Templada will begin at a higher elevation and extend to a higher elevation. The Tierra Fría will begin again at a higher elevation and extend to a higher elevation. And then we think, okay, well, where's the Tierra Helada going to go? Okay, there's no more up. There's no more mountain for it to extend into. So species that are living in these different vertical zones are going to be impacted. And then oftentimes people mention skiing and ski resorts. And in fact, we're seeing already to this day, I know it's happening in Switzerland, it's happening in other parts of the world, where you're just not getting the snow in the locations where you used to. And so you might have built a resort there many decades ago, and now there's no snow in that region. Slide 17. So now let's look at another climate zone and how climate changes are impacting that climatic region. So polar climates, just first of all, there are two subtypes, the tundra and the ice caps. So I'll talk about those, but we're talking mainly about areas of the world such as Antarctica, Greenland, and the land that borders the Arctic Ocean. Slide 18. So the tundra is a climate zone that's been characterized by having at least 9 months of the year below freezing. So take a look at the climograph in the lower right from Barrow, Alaska. And if we look at the red temperature line on that graph, we can see that there's a little bit of time when the temperature is above 0 degrees C, which of course is freezing. Another characteristic of the tundra is the type of vegetation that occurs there. This is an area of the world where we do not find trees, but we find vegetation that hugs the ground, very low vegetation. Another characteristic of the tundra is that the soil actually freezes. The ground is frozen. It's really the moisture in the pore spaces between the particles of soil that freeze. And this adds to the fact that trees can't grow here because the roots of trees cannot sustain being in that frozen ground for 9+ months of the year. So this is called permafrost. Permafrost is a term for that frozen ground or soil. In recent years, decades, in Alaska, for example, the permafrost is not staying frozen for as long. In other words, there are more months of the year or more weeks of the year when that ground thaws. And the particular problem that it poses in Alaska has to do with the Alaska oil and gas pipeline. The pipeline is built above the ground. It kind of has these little support beams, and it holds up this long pipe, which basically brings hydrocarbon petroleum from interior regions where the wells are out to the ports where it can be then transported by cargo ship. So as the permafrost has experienced more thawing, it has actually caused collapsing of the Alaska pipeline. The support beams are sinking into the ground because suddenly you have a muddy, murky, slurry kind of environment that cannot support the pipe. The trucks, the repair trucks that try and make their way out to fix the support beams of the pipeline get stuck in the mud. And students often sort of laugh when we talk about this because it's kind of ironic that it's the burning of fossil fuels that is contributing to climate warming, and the climate warming is preventing, in a way, that oil from getting to port. Slide 19. The other climate type within the polar climates are the ice caps. So this is really the ice sheets of Greenland and Antarctica. And there is no vegetation here. There is permanent snow and ice. There are species that live here, but vegetation is not one of them. So what I'd like to mention with respect to climate change and ice cap climate zones is that there are, and this image, by the way, that we're looking at here comes from from space, from NASA's Earth Observatory. And what we're seeing are on the surface of the continental ice sheets, or these glaciers, are ponds. They're known as melt ponds. And there are regions where big, significant lakes are forming on the surface of the continental ice sheets. Now, for some time, scientists have been trying to figure out what the contribution of these melt ponds are to kind of feedback loops in climate warming. Because if we think about things like how sunlight and how heat is either reflected or absorbed off of different surfaces, we know that ice and water have different albedos. So that's a term that you guys have learned about previously in your reading. So if we have suddenly these big, huge lakes on the surface of a glacier or a surface of an ice sheet, that water can absorb heat more effectively and reflect less sunlight, whereas ice is a very good reflector. So how might that sort of feedback in is that the more water that you have pooling up on the surface of a continental ice sheet will absorb more heat, which can then in turn melt more surrounding ice, which can create more water, which can absorb more heat, etc., etc. So this past year, a group of scientists from Woods Hole Oceanographic Institute went out to the Greenland ice sheet and camped for, I think, about a month on the ice to study these ponds, or these lakes, these glacial lakes, and to see, to understand their behavior. And what they found is that these lakes will actually, the water will melt through into the basal zone, or the bottom of the glacier, and actually create a crevasse, which suddenly the whole lake drains into. And it drains to the bottom of the glacier, and then that water can very rapidly get out to the ocean. And this is one of the mechanisms associated with sea level rise and glacial melt. So I do in Blackboard have a great 10-minute video from that research at Woods Hole for you guys to watch, but this concludes our lecture on climates and climate change. Bye.